Hello, calculus fans. We're going to talk about surface integrals now. This is a generalization of multiple integrals to integration over surfaces. We should think of a surface integral as an analog of a line integral, but now it's like a double integral instead of a single integral. So, if we're given a surface, we're going to define two different types of surface integrals. We're going to talk about the surface integral of a scalar field, and we're going to talk about the surface integral of a vector field. Let's talk a little bit about interpretations of these. Let's first talk about the interpretation of the surface integral of a scalar field. So let's suppose we have a surface, and f of x, y, z is a scalar field. We're going to think of the surface as a physical object, and we'll interpret f of x, y, z as the mass density function, mass per unit area. Then this object here, this surface integral, will represent the mass of the surface. Let's now talk about an interpretation of the surface integral of a vector field. Let's suppose that we have a surface and f is a vector field. We're going to think of the surface as a physical object, and we'll interpret the field as the flow of a fluid, like water flowing around. Then we're going to say that this surface integral of the vector field represents the amount of fluid flowing through the surface per unit time. There's a word for this. It's called the flux of the fluid through the surface. Now, this has obvious applications in hydrodynamics, but interestingly enough, this surface integral has very specific uses in electricity and magnetism. And this idea of fluid flow is something completely different. We'll think of a magnetic field or an electric field kind of like fluid flow, and so flux will represent something completely different. Okay, that's all for now.